Hi, this is the report of the second lab of Introductory Physics 1 of Coursera. In this lab, we're gonna talk about motion of falling objects. Newton's second law. By now, we pretty much know that equation, and with a little act of algebra, we arrive to this representation of the Newton's second law. And in this lab, we're gonna talk about the case where the net force is has two components. First, the weight force, that is the force that the mass of the Earth applies over an object, and it's represented by the gravity constant, the gravity acceleration constant, plus the mass of the object in the contrary direction of the y-axis, that is represented by the minus j hat object, and the drag force, that in this case is a turbulent drag force, that is basically a constant, in this case v, plus the the square of the magnitude of the velocity vector in the contrary direction of the velocity vector. And with a little algebra, we arrive to this representation. Experiment settings. I used two objects. One was a fishing plummet of 110 grams, and a plastic bottle cap that has a mass of 10 grams. I use a book for reference in the tracker, and this is a picture of the simple experiment. This is the work made with tracker. As you can see, I didn't rotate the video, so I rotate the axis. The horizontal line in this tracker is the y-axis, and well, you can see the point of the falling object, and you can see the book used as reference. And in this case, I only will show the motion of the planet. The computational model, well, I use the file lab to start as base. I calibrate the v parameter for the two objects in different way. As you can see, in the case of the planet, there is no drag force, so the v constant is equal to 0, and in the case of the bottle cap is a very small value. Here you can see how the fundamental physical equations are represented in the computational model. Here you can see the model running, and here are the results of the planet. As you can see, the motion of the model without drag is a very good approximation, especially for the last observation. As there is no drag in the model, the two lines are together. In the case of the bottle cap, you can see that there is some difference. The blue line is the free fall without drag, and the yellow, kinda yellow, is the model with turbulent drag. Well, you can see that the fit isn't good. And here is the velocity of the model and the experiment in the case of the planet and in the bottle cap. As you can see, in the case of the planet, the velocity in the experiment is always less than the velocity of the model until the very end of the model, of the period. And with the bottle cap, you can see that the velocity is less than the model, but at the final point, the velocity in the experiment is higher than the velocity of the model without drag, even higher in magnitude of the velocity of the model with drag. So, conclusions. For the fish implement, the model without drag fits somehow well, and it fits very well for the last point. Um, but in the middle of the trajectory, the fit is well. With the bottle cap, in the other case, you have that the model doesn't fit well the trajectory, uh, just calibrating the V parameter to be the same as the last observation, and the velocity of the experiment behaves in an almost contrary way of the velocity of the model. Thanks for watching.